Okay, can anyone tell me what is the meaning of waves? Anyone? Where can we see the wave?
The sea or lake.
Sea or lake? Okay. Swimming pool can or not?
Can any
Swim,
water surface, wet
swim,
surface.
swimming pool only if got anyone there or not? Only if got any movement by someone or some animal, then only can. Okay. So if in the swimming pool is no one is in the swimming pool to make the wave, so there will be a static uh only, right, in the swimming pool. Okay, so Long Man Heng mentioned a physical phenomenon characterized by its frequency, wavelengths, and amplitude. Okay, good. So overview of the topic today is energy transport by waves. Okay, we want to see how much is the energy transported by wave. And then longitudinal and transverse waves. Okay. So after this, you will see the picture of longitudinal is how to draw the wave, and then transverse is how to draw. Okay. Next is transverse wave on strings, periodic waves, and interference and diffractions. Okay. So at the end of this topic, you should be able to define and describe a wave in terms of energy, transport, and intensity. Okay? So we cannot just write the term. Ella, Miss, when is the second class quiz? This Friday already put in the meeting calendar. Okay? Ah.
This the quiz is only chapter 2, right?
Chapter bonding.
Okay, miss.
Yeah, when you do bonding, you must know chapter 1 also. So related to chapter 1. Later I say chapter bonding, but there is some from atomic structure. Then you will blame me also. Never mind. After this, we will do some short revision on the bonding. Okay, we finish up this way first. I have my second dose appointment today at 5. Oh, okay, never mind, Bunny. Later you can see the video, okay? Okay, so now we look at these pictures. A wave is a disturbance that travels towards from its source. When a stone is dropped into a pond, the water is disturbed from its equilibrium position. As the wave passes, it returns to the equilibrium position after the wave passes. The water move up and down as the disturbance move. So in this picture, where do you think the stone is thrown? Is it here in the middle? In the middle, right? Cannot I
Yes, miss.
throw?
In the middle.
Yeah,
Ah,
miss. Middle.
cannot I throw at the side, then suddenly got one round here. Okay. I must throw in the middle, then it distribute to the side. Circular wavefront. Okay. So when do people throw stone in the pond? Huh? Why normally
Anytime.
people anytime?
They feel like throw, then they throw.
They're
Yeah.
stressed with girlfriend. So if you feel like you want to throw no, you want to release stress, then you can throw stone in the pond. Okay, make sure the fish is not there. Okay. It's a way of people to show their anger. Also can. Some people when angry they will play basketball or squash. Even can push the bat faster. Okay. So wave carry energy. Okay, something like you also. You also have energy. When you want to punch people, it depends on your energy, whether you are in an angry state or you are in the full energy, then you can punch people right to the face or wherever. Okay. So energy also like that. Energy carry, wave carry energy. Energy is transported outward from the source. Matter is not transported. So what this means? Matter is what?
Solid, liquid, yes.
Yeah, matter you have three normally. Matter is
The thing
solid.
that occupies space and
Yeah, solid, water and air. Gas. Okay. So this means that uh energy transported, but the water is not transported to anywhere. Water still there. Okay, for example, in a swimming pool, there is an energy transported in the wave, in the swimming pool. But the water still in the swimming pool. Water don't transfer to anywhere. So this means that matter is not transported. The water in the swimming pool not transported to another pool. Okay, something like that. Okay. Okay, so next we will see intensity. Intensity is measure of amount of energy or seconds that passes through a square meter of area perpendicular to the wave direction of travel. Okay, intensity 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 you can see in the torchlight. Anyone have ever used torchlight to find things, for example? Okay. So, some of the torchlight you can rotate and change the setting for making the light more narrow or more spread out. Correct or not, the torchlight? If you want to find things which is at the narrow place and very sharp, you need the light, then you will adjust the torchlight, right? You can move the circular setting in the front. Okay. If you want to find in a wide space, then the light can be spreaded to a wider one, but it is not sharp. The intensity will change. Okay. So for intensity, when it is large or wide, then intensity will be low. Okay, logic. When you want to find things under your bed, for example. Okay, you want to find, for example, coins. Okay, coins. Under your bed is very dark. So, to find coins, you will use a large or wide intensity of the torchlight. But in case you want to find things at a very narrow place at the edge of the bed, so you will change the intensity of the torchlight to a more narrow one. Narrow will equal to high intensity. How about car? Car lighting. Car lighting got high intensity and low intensity also, right? Got spotlight. Other than spotlight, you have the flashlight. Flashlight or the big light. For what? For big light, normally when you see into the roadside which don't have light. At the roadside where the roadside don't have the light at the village area. So you need to use the high lighting for your car. Then only you can see clearly the road. With the help of the roadside lights, then you no need. Okay, you cannot use the highlights during driving in the normal road because you will distract the opposite car. The eyes of the driver from opposite car will be distracted by your lightings. Okay, so don't do that. It will make an accident. It can be the reason of certain accident. Okay, so intensity is important also. So intensity defined is a measure amount of energy or seconds that passes through a square meter of area perpendicular to the wave direction of travel or the average power per unit area. So average power per unit area P will equal to I divided by I times surface of area of sphere. Okay. So intensity formula will equal to power per 4 pi r to the power of 2. Okay, so it comes in circular. The light cannot become square. Okay, you imagine you take torchlight. In your handphone have torchlight also, right? The torch or what, right? So normally student won't carry torchlight. They carry their phone. Okay. So as you flash the torchlight, this will be in circular. That is why intensity formula using 4 pi r to the power of 2. They don't use square formula for the surface area because it becomes sphere shape. Okay. Energy is spread over a large So energy is spread over a larger area as wave move further from point of origin, causing the intensity to drop. Okay. So this statement means that the more far it from the origin, then the intensity will become lower. Okay. Light sources appear dimmer the farther you are from them. And then some energy can be absorbed or dissipated by the wave medium. The amount of energy absorbed depends on medium. Okay, now we look at this example. The intensity of sunlight that reaches the Earth's atmosphere is 1400 watt per meter square. What is the intensity of the sunlight that reaches Jupiter? Jupiter is 5.2 times as far from the sun as Earth. So as a hint, treat the sun as an isotropic source of light wave. Okay. So this is sun. Okay, sun is the source for the light to others. Okay. So here Jupiter is 5.2 times as far from the sun as Earth. Okay. This is Earth, this is Jupiter, more far away. So here they mention the sunlight that reach the Earth's atmosphere is 1400 watt per meter square. From the sun go to the Earth, this is the intensity. Now they want to ask, from the sun go to Jupiter, what is the intensity? Become lower or higher than the Earth?
Lower.
Lower because become far, right? The more nearer to the source, it becomes intensity high. The more far from the source, intensity become low. Okay. So, intensity of sunlight on Earth and on Jupiter. So, formula for I Earth, intensity for the Earth, use power of the sun divided by 4 pi r to the power of 2. Then for Jupiter also use the same formula, but the P is also P sun, but the radius will be different. This one R1, Jupiter will be R2. If got another planet, R3. Okay, different radius. So power of light. Okay, so power of light for Earth is 4 pi R1 to the power of 2 times I Earth. And then R2 is equal to 5.2 R1. This one mentioned here. R2 is far, so R2 is must times the value of R1 times with 5.2. Okay. So therefore, I Jupiter is equal to P sun per 4 pi R2 to the power of 2. Okay. So P sun, we can use this formula. So P sun is equal to I Earth times with 4 pi R1 to the power of 2. Because in the question, they don't give the P sun, power of the sun. If they give, then you substitute here, no need to use this formula. Okay. Since they don't give, you need to use this formula. I Earth times 4 pi R1 to the power of 2. Then this 4 pi can cancel. Then become can you do it on whiteboard? It seems confusing. Which one? This one, just substitute this. What is so confused? This one original, right? This. Okay, look at this. This one original formula. Intensity equal to power per surface area of sphere. Okay. This one is the fixed formula given also in the appendix. Okay. So in this question, only mathematics here. Mathematics is from where? This one is I Earth. This one is intensity Jupiter. Got 2 R. R1 and R2. Which one Muhammad Saad is confusing? Later, simple things also use whiteboard. Other clever student will say, I'm wasting the class time. So I also don't want. I am not teaching mathematics. I'm teaching engineering science. This, if you don't know, you should learn from mathematics. So, if you want me to explain about the Earth and the Sun, can. For the substitution, that one no need. School time also you already know how to do the substitution. Okay, wait. I show. The rest don't know or not also. Because only you request. Okay. So this is sunlight. Okay, easier like this. This is the source from the sun. Okay. The source lighting or the brightness of the sun will go to this one, let's say Earth. We'll go to another one. This one, Jupiter. Not round also. Okay. So here, we will have a circle. Okay. Next. So this one got one radius. Okay. This one is another radius, R2. One is R1, go to here. R2 go to here. This one Jupiter. Got to right. So Earth is more intensity compared to Jupiter, because Jupiter is far from the source of the sun. So R also, R1 is lesser than R2. Okay, what else? Formula for intensity is equal to power of the sun divided by 4 pi R to the power of 2. Okay. Then what else? Okay. So from this formula, you want P sun. So this one just multiply with this. So become this 4 pi R to the power of 2 times I. Okay. Then for this one for the Earth. I Earth. Intensity of Earth. Then intensity Jupiter you can put IJ. So it becomes P sun also because the power only from sun. Unless got another power from something else. Since only one power source, use the same. P sun per 4 pi R2 to the power of 2. This one R1. Because got R1 here and R2 here. Okay, so from this, intensity of the Jupiter is what they ask. What is the intensity of the sunlight that reaches the Jupiter? Intensity don't give. Intensity of the sunlight for the Earth is given 1400. So for the Jupiter, they don't give. For the Earth, they give. Okay. Other than that, oops. Okay. So now we substitute this here. This whole thing put here. Okay, P sun. P sun become 4 pi R1 to the power of 2I. Divide by, copy back this. 4 pi R2 to the power of 2. Only to the power of 2. Okay. Next, whatever that we can cancel, we cancel. So 4 pi can cancel. R1, R2 cannot cancel. Okay. But this is both to the power of 2. So you can do R1, R2 to the power of 2 times I. This one, right? To the power of 2 to the power of 2. Put in bracket. If you don't want, also can. No need lah put in the bracket. Okay. So, it already become like this. The one in bracket just now. Okay. Other than that, question mentioned Jupiter is 5.2 times as far from the sun. Okay. So, this From that statement, you will get R1, R2 equal to 5.2 R1. Okay. You need this to substitute into this to cancel. So, R2 put this 5.2 R1 to the power of 2 times I. Okay. Okay. Then, R1 can cancel this. Cancel this. Then only will become I per 5.2 to the power of 2. That's all. Okay. Then given for the I Earth is 1,400 from the question here. Intensity of the Earth is 1,004. So substitute here. Okay. Divided by 5.2 to the power of 2. Use calculator. 5.2 to the power of 2. 27.04. Then become 51.8 watt per meter square. Okay. So after looking at the solution, you okay? Are you okay, Muhammad Saad, with the solution? Hmm? No answer. When downward was R2, so how it become R1? Oh. R2 not given. Okay. But in the question mentioned, Jupiter is 5.2 times from the Earth. Okay. So that is why we can get the formula R2 is 5.2 times R1. Without this statement, you cannot solve this. You cannot cancel. R2 must put in terms of R1, then only can cancel. Okay? From question. The multiplier. Multiplier the 5.2. Okay? Multiplier given can do. If not, also they can give you the radius of the Jupiter or the distance of Jupiter from Sun is, for example, 10. Then can put 10 inside the R2. If not, cannot. Okay. So concept must understand. If don't understand the concept, picture maybe not given. Okay, certain question Given the scenario but no picture. So must draw yourself. Okay, that is why here I draw. This Jupiter is far from the sun. Okay. Wait ah. Okay, before we go to another part, we will see these notes. A wave is produced when a vibrating source periodically disturbs the first particle of the medium. So just now, for example, you throw the rock. So the medium is the water. When the water at first is not moving, after you throw the rock in the pond, the water become disturbed. So this is what it means. Disturb in the first particle. Second particle, which one? The second wave, you cannot see very fast one. Okay. This create a wave pattern that begin to travel along the medium from particle to particle. Okay, so first particle, then second particle, third particle, so that is the particle. Okay. Or first stage, second stage, third stage. But because too fast, it is maybe in nanosecond. You cannot see from your eyes. The frequency at which each individual particle vibrates is equal to the frequency at which the source vibrates. Vibrates, no, right? The easiest is the phone vibrate. Phone vibration. Move like this. It on the table if you use the vibrate function. During meeting, you can make silent, but the vibrate still on in your pocket. Okay, the handphone in your pocket. Don't put on the table, later vibrate, people also disturb. Put in your pocket enough so that you know there is someone who call you or message. Okay, so vibrates is in frequency also. Vibrate fast or vibrate slow. Okay. So similarly, the period of vibration of each individual particle in the medium is equal to the period of vibration of the source. Okay. So you must understand between period and frequency. Period is one cycle. Period is regarding time. But frequency is how many times? The time. The frequency. For example, traffic light, right? Traffic light have 3 colors. Yellow, correct or not? Traffic light have 3 light, 3 color, right? Okay. So between the green one to go to the red, it will go to the yellow first, right? Then only go to the red. So in that we can read in terms of period. There are some state in Malaysia who have the time, not the time. Yeah, the timer in the traffic light. You can see how long the time, 20 second, 30 second, or 60 second. So green 60 second, then red how long? Maybe red 10 second, I don't know. Okay. So these are the times. The times are called period. But frequency is what? I wrongly press you. So, compared to frequency, for example, traffic light, frequency is how many times the green light on in 1 hour. So, red color also, how many times the red color on in 1 hour? But the period, we don't know, right? The frequency we know. But to know frequency, we must know the period. Period equal to time. Okay. If you forget, you imagine traffic light. Okay. Traffic light have 3 colors. Normally, the green one will be longer. How long the green light on? Okay. How long the green light on is the period. But how many times? How many times the green light on? That one is the frequency. Frequency is how many times? Frequency. 20 to 30 second. I also don't know. Okay. But the government have create a good solution by putting the yellow light. If not, suddenly from green, suddenly brake become red. You brake your car, behind car knock you. So, some state, before turning into red, the green will be blinking first, then only turn yellow, then only become red. Blinking is to show, oh, quickly go and drive faster. For me lah, I don't know for you. Maybe for you, oh, prepare to stop. Depend on people. If people want to rush during the yellow, can still go. Depend on road also, which road. Later got blind people there, you go and knock them. Problem also. Okay, depend on road. Which road you are using. Got camera or not? Okay. So got camera or not? Camera can capture you already pass the red light but go and drive. Yellow is slow down. For us is go even faster. Sometimes we rush to go to class, right? Samuel. Want to fetch girlfriend? Oh, I will fetch you at 8 p.m. It's 7:55 still at the traffic light. How? So depends but as long you look at left, right, and right first. Okay. So I just want you to understand between frequency and period. How many times you drink coffee in one day? Period. Till how many hours you drink once the coffee? Different, you know. For example, how many frequency you, how frequent you visit your mother? Once a week, once a month, or once a year. But then, by using time, I visit her 2 days. 2 days for each time 2 days. Different. So you must know between frequency and period. Then only you can understand this concept. Okay, in one period, the source can be particle upward from rest, back to rest, downward from rest, and finally back to rest. Later you read this, you also become crazy. Okay, so to make the understanding better for the period, you can draw a graph. Okay. Draw a graph. So then there is a waveform. This x-axis is time. This one can be voltage. So according to this, go up and down and then go down to up. This is means for one cycle. From 0, go back to 0. This is T. T equal to period. Okay, if you don't want from here to here, you can from peak go to peak. Same also. This to this also T. Okay. So, from the time or frequency, can be getting the frequency from the formula 1 over T. Okay. So, if you know the period, you can know how much is the frequency. 1 over T. Okay. That is the first formula. So, if 0 time, it will be 0 second. 0 second, no movement. 0.25 period, got some. 0.5 period, got half of the waveform. 0.75 period, got 3/4. And then 1 period is from minimum go to maximum, go 0 balik. Goes 0 again. Okay. So this is the same as this. This 0.5, this one half. So where is the 0.5? 0.5 is here. 0.5, this one 1. This one 0.25, this one 0.75. Okay, total 1. Okay. The diagram is the snapshot of the production of wave within a rope. The motion of disturbance along the medium after every 1/4 of the period is depicted. Observe that in the time it takes from the first to the last snapshot, the hand has made one complete back and forth motion. So this is hand. Hand trying to move the rope. After certain times, a period has elapsed. Observe that during this amount of time, the leading edge of the disturbance have moved a distance equal to one complete wavelength. Okay, so finally get the formula. Formula for speed is equal to wavelength per period. So speed is equal to wavelength times with frequency. Okay, the above equation is known as wave equation. It states the mathematical relationship between the speed v of a wave and its wavelength lambda and frequency f. Using the symbol v, lambda and f, the equation can be rewritten as v, or the speed, will equal to f times the wavelength. Okay, so this is one formula, another formula in this chapter. V equal to F lambda. Okay. Next, we will go to transverse and longitudinal waves. So, transverse wave is where the motion of particles are transverse to the direction of wave travel, result from a shear disturbance known as S wave. Example are electromagnetic wave, light and microwave. So light is considered as transverse wave. Particle displacement is perpendicular to the direction of wave propagation. So as you move with two hands, this spring, okay, it will go up and down. Okay. So longitudinal waves is where the motion of particle are along the same direction as the wave propagation, result from compressional disturbance, known as P waves. Just now S wave, okay, got two different names. And then sound wave in air is considered as longitudinal wave. Particle displacement is parallel to the direction of wave propagation. So now, when you pull, when you pull the spring left and right, it will follow also the motion left and right. It don't go up and down. Compared to this, you push up and down, motion of wave is left and right also. But the changes is up and down, which is perpendicular. Perpendicular means 90 degree to the movement. Okay, perpendicular equal to 90 degree to movement. Sometimes forget also, perpendicular is what, parallel is what, parallel same with movement. Perpendicular is 90 degree with the movement. Okay. So here it looks like going to the right, right? Okay. Motion of particles. Both types of wave can move through solid. For example, sound, right? Sound, even though you talk in the living room, can be heard in the room. Even though there is a solid wall. Wall is made of solid. Consider solid wall. Wall can be made of bricks equal to solid. So that means that longitudinal wave can move through solid. Transverse wave can move along the surface of fluid due to gravity. So now we look at transverse wave on a string. Attach a mass to a string to provide tension. This one is the mass put to a string to provide tension. The string is then shaken at one end at a frequency f. Okay. So you shake the string. The wave traveling on this string will have a speed of v equal to square root of f per mu, where F is the force applied to the string and mu is the mass or mass per unit length of the string, where mu equal to m per L. But provided you know the length of the string. If not, they must give you the mu to substitute into this formula. Okay, now we look at this example. A string of length 0.5 meter has a mass of 125 milligram. Okay, same like the just now one, the slide. So this is string, this is the mass. The string is attached to the ceiling and a pinata of mass 0.5 kilogram hangs from the other end. A child whacks the pinata sideways with a stick. Okay, with this got children. Children whack this pinata sideways with a stick. As a result, a transverse pulse travels up the string towards the ceiling. At what speed does the pulse travel? Okay. So this means that even though the children is moving it sideways, left and right, but this go up a bit also. Okay. So the tension in the string is equal to the weight of the pinata hanging on the string. F equal to mg. The speed of a wave on a string is v equal to square root of f per mu. Mu equal to m per L. Okay. F equal to mg, substitute here. Then the L here, because if put down here difficult to calculate, L go up. 1 per L become L. When go up, right? Okay, then easy to calculate a bit. Okay, next is the mass. Mass is 0.5 kilogram. G 9.8. L is the length of string, 0.5 meter. If this is in centimeter, convert to meter. Okay. Divide by M. M is the mass of string. Okay. There are two mass. Later don't confuse. You substitute wrongly this one. Okay, mass of spring. No, mass of the string. Mass of string is 125 milligram. So 125 times 10 to the power of 3. Milli is 10 to the power of 3. But then how become 10 to the power of 6 here? Negative 6? Because here if you put 10 to the power of 3, you haven't convert to kilogram. You are just 125 milli, you convert to gram also, still in gram. So milli convert to gram, gram convert to kilogram, you must divide by 1000. So milli become micro, 10 to the power of negative 6. Okay. Then equal to 140 meter per second. The speed of wave on string. Okay, understand this example. Okay. So let us look at this question. Electromagnetic wave can travel through transparent dielectric media or through a vacuum. Give 5 examples of electromagnetic wave. So examples can be radio wave, infrared radiation, visible light. Visible light is normal light from the sun. Ultraviolet radiation, X-ray and gamma rays. So all these waves can travel through transparent media. Ultrasonic cannot. Okay. Ultrasonic wave must have non-transparent. For example, you use wall can. If glass cannot. Glass transparent. Okay. Ultrasonic wave used in where? Still remember or not?
Used for the sonar.
Yeah, used in where?
Sea.
Okay, can also. Ultrasonic used in the car reverse sensor. Okay. Used in the car reverse sensor to detect something at the behind the car. Not necessarily behind. It can be at the side, on top or at the bottom. At the area which can be in the area of the ultrasonic wave. Okay, for example, X-ray, all this you know right where to use. Okay. Next. Next is periodic wave. Periodic wave repeats the same pattern over and over. Terminology for periodic wave is similar to that used in SHM. Simple harmonic motion. The one that you do the pendulum. Okay. The period T is measured by the amount of time it takes for a point of wave to go through one complete cycle of oscillation. Frequency F equal to 1 per T. Okay, so just now we have seen the period. Period is from minimum go to another zero. From zero go to another zero. Okay. So repetition of distance is equal to lambda. For periodic wave, V equal to lambda times F. This is a fixed formula. Where V equal to wave velocity, F equal to wave frequency, and lambda equal to wavelength. One way to determine lambda is by measuring the distance between two consecutive crests. Crest is here in the peak. So peak go to another peak, we can measure the lambda. Amplitude is maximum displacement. Okay, so maximum displacement, for example, 0 go to here. So this is amplitude from 0 go to A. 0 go to bottom is negative A. If bottom to highest, that is voltage peak to peak. But we don't use voltage in this waveform. We use amplitude. Okay, amplitude A is maximum displacement. Displacement is what? Changes of the place. Okay, displacement. In this case is light. Changes of light from where go to where. Okay. So, for example, what is the wavelength of a wave whose speed and period are 75 meter per second and 5 millisecond? Period is 5 millisecond. Then use the formula to find the wavelength, lambda. So formula just now, V equal to lambda times F. V equal to, lambda don't know the formula. Lambda symbol cannot type here. Lambda times with F. Okay. Okay. So V 75 meter per second. Already meter, no need to convert anymore. Yes. The notes just now. Yes, can. Period of wave T. T is 5 millisecond. Okay. Next, solving for the wavelength V equal to lambda times F. F don't have. In this question, they don't give you F, or frequency, they don't give you. So you can replace with F equal to 1 per T. That is why now T at the bottom. Okay. T is 5 millisecond. So lambda is equal to V times T. Okay, lambda equal to V times T. V is 75 meter per second. T is 5 millisecond. Must convert to second, the unit SI. Okay. Second unit SI. Millisecond cannot convert to second. So must multiply with 10 to the power of negative 3. Equal to 0.375 meter. Okay, easy only, right? As long you have the formula, you can substitute with the value given in the question. Formula provided, no need to memorize. But for example, this is V equal to lambda F. Then you, let's say you forget, frequency not given. How I find the value? So you must refer to another formula, F equal to 1 per T. Then only you can use the T. You must know how to manipulate the formula. Okay? Okay, we will not enter superposition because too much already. Wait for a while. We will be doing the wave calculation later, not today. Okay? There are many questions that will be discussed later. Wait, So now we will look at the video for more understanding about the wave. Wait for a while. Okay.
Amplify your lessons on waves and sound with these terrific demonstrations using tuning forks. The sound from a vibrating tuning fork isn't audible all the way across a classroom, so you can increase the amplitude by touching one of the tines to the edge of a piece of paper or plastic dish. Show students that the tines are vibrating by lightly touching the fork to a ping pong ball hanging from a string. Demonstrate that the vibrating tuning fork sets the adjacent air molecules in motion with a cup covered with plastic and pepper sprinkled on top. And it's always fun to dip a vibrating fork in a cup of water. Try a different frequency to see which makes the bigger splash. Use a stroboscope to create the illusion that the tines are moving slowly, and students will see just how far they oscillate. Combine science and music by creating a C major chord. With these demonstrations, your students will really get in tune with the concepts of waves and sound energy.
Okay, what you understand from the video? Okay, we will look at one more.
Mr. Reeves here. So I want to do a demonstration of sound waves for you. And to do that, I've got these devices. They're called tuning forks. Each one produces a different frequency. Can you predict which one has the higher frequency? I don't know. Think about it. All right, let's try the little one first. So I'm going to bang it on the table and listen to the sound. hurts my ears from here. All right, and then let's try the bigger one. This one's longer. So what did you predict? Yeah, this one's the lower frequency. Okay, the longer it is, the lower the frequency. Remember, frequency is vibrations or pitch, right? Okay, you can do something really cool with these. I'm gonna take the bigger one. I've got a little bowl of water here. It's gonna get a little crazy. I'm gonna take this and I'm gonna hit it hard on the table. And I'm gonna put it in the water, watch. Oh, you see the water shoot all over the place? I'm gonna do it one more time. You can't see the forks moving, but when you put it in the water, you could clearly see the energy and the speed at which those forks are moving when it has that sound. So let's try the little one just for fun. Okay, here's a little one. Probably not gonna move as much. Oh, let's try it again. Whoa, that one worked good too. All right, hope you guys enjoyed the video. Take care.
Grammarly does more than catch errors. With Grammarly,
Okay, understand already the concept of the tuning fork. So this I have put the link here together with the wave question later we will do during tutorial. Because today half of the class we will session on the coming quiz. Okay? Wait So for the coming quiz, we will concentrate on the bonding chapter. Already expert in it, right? So in the bonding chapter, you must know the shell. Basically, the shell is from K, L, M, and N. Okay, what else? And then some electron configuration, whether stable or not. Atomic value, you must know how to get it from periodic table. After that, between ionic, covalent, and metallic, which one is the strongest bond? You must know how to differentiate between ionic and covalent. Okay, other than that, when some element is mixed or bonded with another element, for example, magnesium bonded with oxygen, so it becomes MgO or Mg2O or MgO2. Okay, so the formula that happen after the bonding, you must know how to find. Okay. So based on this, magnesium magnesium is 1s to the power of 2, 2s to the power of 2, 2p to the power of 6. Total is 10 here, plus 2, 12. Okay, so this 12 to become stable, this 3s2 is removed and bring to the other element, oxygen. Oxygen atomic number is 8. 1s to the power of 2, 2s to the power of 2, 2p to the power of 4. So, so we must make a stable one. Therefore, we will donate 3s2 to oxygen here. When you donate, the Mg not become minus, become plus. It's opposite of what you say. You say donate, you give something to people. But in chemical, when you give something, here you will put 2 plus, not 2 minus. Okay. So it becomes Mg2 plus. So Mg just now is 12. 2, 2, 6, 10. 10 plus 2, 12. 12 minus 2 become 10. So final will be 2 to 6 only, 10 total. Okay. So between Mg and Mg2 plus, different formula for atomic electron configuration. Okay. Next, for the oxygen. Oxygen receive accept 2 electron from the magnesium. So when accept, oxygen become oxygen 2 minus. So become 2 to 6. So 2 to 4 add with 2 become 10. So this is MgO. Okay, then become Ne. Ne from the periodic table is 10. Okay, here. Okay. Other ionic bonding example is sodium with chlorine. Other than that, you must differentiate between ionic formula given with covalent and metallic. So if they give you the name or the formula, you must identify it comes from ionic, metallic or covalent. How many questions will be coming in quiz 2? Same like quiz 1. One question with subdivision. Same style. Got 1 A, B, C until F. Only one question, but got subdivision. Okay. After that, you must know how to illustrate the bonding structure. Means you must draw. Already do, right? Previous classes. Wait, I open one. Bonding. Okay, for example, this. For example, illustrate when magnesium is bonded with fluorine. Okay. So how to draw? Illustrate means draw. But also illustrate sometimes can be in terms of sentence. So first, when you get this type of question, you must refer to periodic table. Okay, so refer to magnesium. Mg, this. Mg you see in the periodic table is 12. So you jot down 12. And then fluorine. Fluorine you jot down 9, atomic number 9. Okay. After you do that, you need to draw the magnesium first. So 12 is 2, 8, 2. Separate into the shell. Shell number 1, 2. Shell number 2 is 8. Shell number 3 is 2. Okay. Then 2 is not stable. When not stable, you want to donate these 2. Donate to where? To fluorine. Okay. So next you draw fluorine. Fluorine is having 9 atomic number. So it is 2, 7. 7 is not stable in the shell. Valence. So 7 must add with 1. Become 8 only become stable. So the one you add with the donation from magnesium go to one of the atom here. And then one more go to another fluorine. Okay. That is why you have to draw 2 fluorine. If you draw 1 only, not enough. Here donate 1. Here want to donate 2. So draw 2. Draw 2 fluorine. After donate already, then the fluorine becomes stable. 2, 8 here, 2, 8 here. Okay, anything want to ask? Okay, right. This. Okay, next we look at the sodium. Sodium plus oxygen. Okay, this must refer to periodic table first. Sodium is which one? You think it is SO, but it is Na, the name. So sodium is having 11 atomic number. 11 when you separate into shell become 281. So 1 is not stable. 1 must be donated to another place. Okay. Then after that, oxygen. Oxygen, if you refer to periodic table, is 8. From 8, you separate into shell. Shell number 1, 2, shell number 2, 6. So 6 is not stable. 6 must add another 2, become 8, then only stable. Then to add with 2, not enough to have 1 sodium only, because here got 1 only, you need 2. So you need to draw 2 sodium. Na go to here, this one Na plus go to here. When want to donate, the Na become Na plus, not Na minus. Okay, always remember in chemical, whatever you do is opposite of what you write. Okay, this one donate, actually minus. But when you write plus, here also same, Na plus. So when you have two Na plus, it becomes Na2 plus. Okay. After that, these two become 2,6 change to 2,8 for oxygen, which receive 2 electron. Therefore, oxygen become 2 minus. Okay. Understand, right? Okay, what else? Other than you draw, this one you draw. Okay, means they ask you to illustrate what happened in the bonding. Whether join together, whether separate, you must show in the diagram. So prepare 2 different color at least for easy checking. Okay. Other than that, okay. This one you are asked to sketch or illustrate. Next, you also have question which are given the figures. The bonding picture given to you. Then what you need to do? Anyone know what to do after they give you the picture?
Name the bond.
Yeah, name the bonding name. Is it MgO? Is it NaOH? Is it CO2? Okay. You must know the indication whether 2, 3 or what. Okay. So, question can be sketch. Wait, sketching the bonding, or determine the name of the bonding. Not the name and formula. If you don't know the name, how you know the formula only? What you can do, you can Google, right? If you cannot Google, you can find in notes. If have, if don't have, means you need to refer to chemistry book. More difficult. The best is to Google. Okay? Let's say you know how to draw. Then you already draw. You don't know the name. So, need some practice. You have another 2 days to practice. Tonight, tomorrow. The exam. The quiz will be Friday 2:30. 1.5 hours. Okay. Are you ready to take the quiz? Ready?
Not ready.
Not ready. You can do some tuition with your friend. Okay, next we look at the bonding of selenium and oxygen. So, selenium, you refer to the periodic table. This, 34. Okay, 34. So first jot down 34. Don't be expert straight away. Do this. Later you wrongly separate also problem. So 34 is 2, 8, 18, 6. This refer to the maximum electron in one shell also must refer. Okay. In one shell, what is the maximum? 8 or 2? Okay. After that, you need the 6 here is not stable. 1, 2, 3, 4, 5, 6. For illustration, you can put dot or cross or X. Okay. So the 6 not stable, must take some from oxygen here. Oxygen is 2, 6. 6 also not stable. So can become another 2 to become 8 here. So you want to add here or here? Here is the fastest because you need to add 2 or here also 2. Okay, so 2 here become oxygen 2 minus from 2, 6 go to 2, 8. Okay, so this needs some practice to do all this.
Wait, Miss cannot share.
What?
And
Ah,
this one cannot share.
share what?
Share electron.
Cannot share. Selenium plus oxygen.
Yes.
Wait ah. Cannot bond ah.
I know, I'm just asking like, can we use share bond for this one?
Wait ah, I check. I think cannot lah. Because selenium burns in the air. Selenium burns in air, displaying a blue flame and forms solid selenium dioxide. Selenium oxygen 3. SeO3.
O3
The
means it donate all 6.
SeO3, the formula.
Okay then.
Okay. Don't worry, your quiz not that difficult. Other than that, what else?
Miss, the quiz 2, right, will come out diagonal rule.
Diagonal rule.
Yeah, quiz 2 will come out for the diagonal rule.
Like not related also.
Oh, just bonding questions.
Yeah.
Okay.
But question have theories also. Okay, theories can be I cannot tell you lah. So theories regarding ionic covalent, because not many that topic. For bonding, not many the topic. Too narrow. Okay, so you can, I think you can score. Because the total question is for 30 marks. Okay. The one to draw is the one to draw is just 6 marks. But maybe take time to draw. The one that you interpret from the given figure, that one is also less marks, is about 4 marks only. So even though the time given is 1.5 hours, you can finish it faster, I think. Only some theories that you need to find out. Find out
Excuse
or
me, ma'am.
study. Yeah.
Ma'am, selenium plus oxygen is the ionic bonding or covalent bonding?
Not sure. Whether ionic or covalent, you can see whether it is joined or finished.
Since this one is donate, this one is ionic bonding.
This one ionic. You must differentiate ionic and covalent. So just now Pritakon say this is ionic because what?
Because one donate, one receive. If share, then only covalent.
Because
share,
one donate, one
other
receive. So if covalent, how? One only give.
No, both must share with electron with each other.
Both share, the picture different already, right?
They join
This one, the
together.
picture separate. So covalent share the what you call this elements picture elements diagram. Because this one just now all I show is from this. Wait find one sample of the this. Just now ionic, right? This one, if not donate and not receive, it is sharing. So if sharing, covalent. Like lithium and oxygen. Lithium is 3, so become 2, 1. Oxygen is 8, so become 2, 6. So you no need to draw the separate one. You can draw this directly also in the quiz. Okay, draw the final look of the element bonding. If separate, separate. If join, like this. For example, here boron and fluorine. Boron 5, so become 2, 3. Fluorine 9, so become 2, 7. Then only you can draw this. If you don't want to draw this, you can draw this directly also. But for me, I draw one by one first. So I know how many to add here. Because here is 7. So 7 to become stable must be 8. So this blue color is the 7 one plus 1 in the 8. Become 8. So boron is 3. 3 will not become 8 also, right? To become 8, this 3 need to have 5. 5 more to become 8. But here, only 3. So whatever that you put the 3 element, let's say this one, fluorine, 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 got 3 fluorine. Then 1 only boron. So formula become BF3. Okay. So it is enough if one of the element is stable. No need both. For example, here fluorine at 1 here, right? So become stable fluorine, here fluorine stable, here fluorine stable. But boron actually after combine, boron become 2, 6. Can see got 6 element here lah. Okay, at the valence. So you only care if one already stable, right? Later you think so much also you confused. Selenium is metalloid. In periodic table, selenium is non-metal. Ionic bond involve metal and non-metal. Selenium is non-metal. Okay. So to know whether it is metal or not, you can see this periodic table. Don't see the others. There are many periodic table, but the one which is easier to see is this with the color. So just now selenium is non-metal. Mixed with, just now in the picture, oxygen. Non-metal mixed with non-metal. Okay. So become covalent. Okay, other than that, you must know the example of covalent and example of ionic, example of metallic. Okay, if there is a list, there is a list of chemical given. You must predict, not predict, actually must know. Must write down whether that formula is for covalent, for ionic or for metallic. Okay, you must write down. Okay, I think you can do fine, right? The quiz. Don't worry, your quiz is 15% only. There are some students who don't come. Maybe not you lah. Because they say, oh, I lazy lah, want to learn this chemical thing, I will score my assignment. Up to you, that is your choice. From the 15, if you get half, you get 8, right? 8 also can change the grade. 8 is also important. Actually, we make the quiz to help in those who want to pass. Because exam difficult. If you study, not difficult. If those who don't study. Okay, exam quite challenging. Got many chapter, right? Don't know which one to learn. But quiz is easy. Quiz focus on certain chapter only, not a large chapter. So you can score. At least from the 15, you can get 10 lah, minimum, I think. Because you also don't do the quiz in class. If in class, you cannot refer to books, cannot refer to phone. Phone put in front at the lecturer's table. Cannot talk to friend. But now during online quiz, you talk to friend also. I don't know. That's why if online all, you must take this opportunity during this online time to score all subject. Later you go second year, all this don't have already. Okay, COVID is finishing already. In October, they said need to go campus. Tentatively 18 October, not sure. Haven't announced the real yet. Okay. So hopefully we can see each other in the class in APU. I encourage you to come to class. It will be a hybrid class. Hybrid means half online, half face-to-face.
When is that, Miss?
Not sure whether it depend on situation of COVID. Are you in Malaysia, Ella Alam?
Yes, Miss, I'm in campus.
Oh, in campus okay lah. But only the 2 dose can enter campus. Already 2 dose or not all? Hopefully no need the 3rd dose lah. Because in Malaysia, got in news also, right? Got 3 times, right, the dose to make yourself more immune. Booster 3rd dose. Later need to become fever some more. For youngsters, maybe no fever. For old people like us, we can become fever a bit. So every day eat vitamin C, vitamin E, whatever vitamin to be a strong body, to build a strong, fit body.
Okay, bye, Miss. Thank you.
Okay, thank you, Muhammad Saad. It's not 6:15 yet. Another 3 minutes. Anything want to ask for quiz? For quiz, if you confirm your handwriting is neat, you can use A4 paper because there are some drawing to draw. If you think your handwriting is untidy, please use line paper. 1 minute left. Okay. Okay. So that's all for today, class. Good luck for your quiz 2. Hopefully all can score. I have
Thank you, ma'am.
uploaded your assignment in the Moodle. Okay, you can look at it. But assignment submission is 20th October. Okay. About 3 weeks from now. Prepare
Ma'am,
your...
can you will explain the assignment later on how we can do it?
It's already in the question. I will explain again. After
Okay,
your
thank you,
quiz.
miss.
Okay. Okay,
Okay,
that's
thank you,
all.
miss.
Good luck. Your quiz this Friday. Don't absent.
Miss, which part of
Okay,
Moodle
thank you,
I don't
miss.
see?
Okay. Sutesh want to talk?
Yes, Miss, you said you have posted the questions, right, for the
Ah,
assignment.
yeah.
Well, I don't see it in Moodle.
You don't see in Moodle where I open.
Miss, you just publish it in the Microsoft Teams there only.
Got in Moodle also. Wait Engineering science. Here Under individual assignment here. Who say cannot find?
Miss, you see the thing right there, hidden from students.
Uh-oh. Okay. Later we'll hide the quiz one only. Okay. I will change this setting. Then editing on. Okay, I will do this later. Thank you all.
Okay, thank you, Miss.